Okay, we're going to get started. So hello, everyone. Thank you for joining us for the PIEVC Practitioners Network webinar titled Climate Resilient Infrastructure, International Experiences and Integrated Solutions. My name is Suzanne Sealing, and I'm the Community Manager of the online PIEVC Practitioners Network. Before we get started, I just have a few housekeeping items to go over. So if at any time during the webinar you have questions or experience technical difficulties, click on the chat box, find my name under the drop-down menu of participants, and send me a private direct message. I'll do my best to help you. Please note that your microphones have been disabled, but you're welcome to turn on your video. We will have a dedicated Q&A session at the end of the webinar. Please use the Q&A box to submit your questions. You can vote for a question that has already been submitted, and we will address questions in order of the most votes. We encourage you to use, I'd also like to mention that we are recording the webinar today. I'll be sending out a copy of the recording to all those who pre-registered, and it will be posted to the PIEVC Practitioners Network. We have an engaging webinar planned today with polling questions throughout. We are using an application called Mentimeter. Nicholas, I'll just get you to change the slide, advance the slide if you can. Thanks. So we're using Mentimeter to collect your responses. Instructions to access the polling are shown on the screen. You'll just go to menti.com, enter the code shown there. Alternatively, you can use the QR code to access it. Now I'd like to briefly introduce today's speakers. Dr. Nicholas Baumert is head of the Global Project Climate Services for Infrastructure Investment, CSI, with GIZ. We have Eric Sparling, is Vice President at the Climate Risk Institute. Benjamin Huddock is a Project Director for the Transboundary Water Cooperation in the Lower Mekong Basin. Paul Cobb is Manager of Training Services at CRI. And finally, Katerina Lotzen is a Policy Advisor for Disaster Risk Management with GIZ. Thanks for joining us today, everybody. And so with that, I will pass it off to you, Nicholas.
Yes, good afternoon, everybody. Good afternoon from Nairobi, sitting here in Kenya. I would like today guide you a bit also through this webinar, and I'm very happy that you're all joining here. And I would like just to state here the objectives of the webinar to make that clear. You probably have seen that also in the flyer, in the announcement. So we would like to disclose the lessons learned that we gained in a project called CSI Climate Services for Infrastructure Investments in the past 7 years about implementing climate risk assessment of infrastructure assets and portfolios using the methodology of the PIEVC, which is called the Public Infrastructure Engineering Vulnerability Committee, and its implications for infrastructure investments decision making. So because it will set this scene for later disclosing to you also and to offer you and to showcase to you, to present to you the integrated solutions and advisory modalities for climate resilient infrastructure investments that to be acquired in a kind of project context that deals with infrastructure development. Having said that, I will go to the next slide and just show you a bit the structure of the webinar. It has not been seen yet by everybody, of course, in the leaflet. It was not shown how we go about today. We have this part one now with the introduction, welcome, setting the scene. We shortly introduce you to the climate risk of infrastructure nexus, a kind of a small presentation to set the scene also here. And in part three, we would like to disclose the concept of climate proofing and showcase the lessons learned from the CSI project, and then come to the PIEVC services that are offered and how they are structured, how they can be acquired, what are the mechanisms of delivery, and so forth. This will be shown in part four here. And then in the part five, we also try to give you advice on how you would go and forward with engaging with PIEVC services and how you maybe join the community that is slowly and gradually growing. Yeah, and to set the scene now, I think it's good to have a use case here for acquiring PIEVC integrated solutions and services. And I understood that a ban being placed in Laos at the Mekong River Commission has issues with infrastructure in your context of work. And I would like to know from you, also having been the project head before long on the CSI project, where you, of course, are very knowledgeable of what has happened so far in the CSI project, and especially the results that we have achieved. But from your new position also, what are the kind of services that you would acquire to advance on this topic of resilient infrastructure? Because I suspect resilience is a question, resilient infrastructure is a question in your scope of work.
Yeah, thank you very much, Niklas. Thanks for the invitation, and also a welcome from my side, and hello from Vientiane in Laos. Yes, it's correct. So it's nice to see some very familiar faces also, and also happy to listen to further questions and stories from colleagues and partners around the world about the topic. As you have just mentioned, I have kind of changed the sides, and since we worked together for a very long time together with our Canadian colleagues and friends on the PIEVC methodology for climate risk assessments of infrastructure, I'm now joining, or I have now joined a new project working with the Mekong River Commission, the Lower Mekong Basin, supporting countries like Vietnam, Cambodia, Thailand, and Laos in various matters related to integrated water resource management. And as the name already says, Transboundary Water Corporation, it's not mainly an adaptation project. It's not mainly a climate change project. And it's also not mainly an infrastructure project. And yet there is a number of connections to gray infrastructure, to green infrastructure. It's a matter of water and hydro infrastructure, and various transboundary issues between countries along the Mekong and its tributary rivers in the Lower Mekong Basin. We are now planning for a next phase. The project has been ongoing for almost 3 years now. The whole cooperation with the Mekong River Commission between Germany and the MRC will celebrate its 30th anniversary next year. And it's time to look into climate change adaptation as well. And we have been working for a number of years now on issues related to flood and drought management in transboundary areas. And we have experienced a number of disasters and various hazards related to flood and drought for people, for infrastructure, but also for the livelihoods of the people. And to bridge the gap now, and to also kind of set the scene towards other colleagues from other projects around the world, but also colleagues from partners around the world who are implementing various projects and measures, I would like to also say that we're having a number of questions, and I hope these questions can be answered either tonight through this presentation, but also in the medium and long-term run through further cooperation with the PIEVC. And in our case, it is now the of implementation. I guess in most cases, people think they know what the solutions are. Flood and drought issues related to reservoirs, related to irrigation infrastructure, but we are now facing a situation where in the past many studies have been undertaken related to the history of climate hazards. We have good knowledge about various vulnerabilities and exposures, but there are a number of missing gaps. One missing gap, for example, is projections of the future. Nobody knows what is going to happen. Nobody has yet projected what is going to happen. And are hazards going to be more extreme? Are we facing more extreme weather events in the future? And how is the infrastructure equipped regarding these potentially increasing and more extreme hazards and events? So there are a number of questions, and I guess what we have learned over the last years is that we need to know the projections, and we need to know also what the risk level is before we really come up with working solutions. In many cases, I guess projects think they know already what the solutions are. In our case, we have also already proposed ecosystem-based adaptation solutions, a combination of green and gray. But if we look further down to the local level, it is not clear whether these services or these adaptation measures will really work, really correspond to the risks, because they have not fully identified. And to avoid maladaptation in the long run and also lock-in effects, I guess it is really important that we figure out in a number of assessments what the risk level towards climate change really is. In some cases, this seems to be extra work, but I think we need to go this extra mile also to really know. And in our case, it is also, at the moment at least, not so important to engage in further longer capacity development measures. We really just need the products to assess the climate risks and then to further continue with our adaptation measures, where we also gain some implementation and investment money to really go for the adaptation measures. So as far as I understand this, and as far as I can see, PIEVC has been evolved from a methodology to a newly service offer. And I guess it would be interesting for us and our project, but probably also for other colleagues in the region, to learn what this offer could be and how this could be integrated in our already ongoing and existing project, to make an effort in adaptation and to, of course, grow with the resilience efforts here in the region, the 4 countries. So much from my side. Nice to see you again, and I'm very interested to listen to the presentation and to see what the final service will look like. Thank you very much.
Yes, thank you very much, Benjamin, for setting the scene here. I think you had the point really that PIEVC is an evolvement from a methodology to a service, and that climate risks have to be more and more being considered when adaptation options are being selected to avoid maladaptation. And it's all about the seminar, to disclose to you what these services are. But before we go there, we would like to also get to know you. And that's why I would hand over again to Suzanne to start with the polling.
Okay, so head to menti.com and enter the code. You can also use the QR code shown on the screen there. And the question should be up, but let's...
Yeah. Shall I stop sharing? No.
No, I think you and I can share at the same time. So that should be up there. I just need to... Okay. So the first question is, what is your affiliation? So there should be options on the right when you're in there, when you're in Menti, to enter your affiliation. So majority from GIZ, we have some Canadian representation, private sector, and 1 partner of GIZ. Great.
Suzanne, just to let you know, in case it was your intention to share your screen, that we're not seeing it.
Oh, it's not showing?
No,
Oh.
not, at least not for me. Now? No? It's bizarre. Okay, Oh,
anything?
some can see it.
There we go. Now?
They see the screen. That's good.
Okay. Okay, let's go to the next question. Have you ever participated in a PIEVC assessment, whether that means you've led one or you had some other role? So far, oh, pretty close, 50-50, 11 say they have and 12 say they haven't. Great. Okay, next question. What is your work relationship to the topic? So resilient infrastructure. And here are short answers. You just enter a sentence or a few words, and we'll be able to see. Okay, so dam safety, an analyst, flood and drought management, quite a diversity, so coordinator, new player in the field of adaptation, learning the ropes. That's great. We welcome early learners. Developing methodologies on the topic in urban transportation. Great, great. Great responses, everyone. Thanks.
Great. So we continue, right?
That's right. So,
I think it's time to continue now. We would hand over now to Eric to a bit tell us about the nexus between infrastructure and climate risk.
Perfect. Do you hear me okay? Coming through? All right. I'm with you today from Ottawa, Ontario, Canada, and it's great to be here. So I'm going to take the next few minutes just to address the question of what are we actually talking about when we refer to climate risks of infrastructure, and as Nicholas will speak about a bit more, the climate proofing of infrastructure. So if you can move on to the first slide. Great. So as we do this, let's start by defining what we mean when we say infrastructure to begin with, and particularly, I guess, when we talk about public infrastructure assets. So infrastructure assets are anything that delivers value to an organization and the stakeholders it serves. And on the public side, public infrastructure assets are those that are owned and managed by the public sector to deliver services to residents, businesses, institutions, and economies. So in this picture, the roadway, walkways, storm and water infrastructure, perhaps also internet and electricity, depending on jurisdiction, may be among the public infrastructure assets we see. And of course, people in many places, everywhere, interact with infrastructure of one sort or another every day, but may not think about these systems as infrastructure and may not think about them much at all. In many cases, they're out of sight and out of mind. But organizations that own these assets need to think about operating them in ways that will continue to deliver services at expected levels to the public. If you can go to the next slide, please. So in addressing public infrastructure, it is important to think about who owns and manages these assets. So local government, as you'll see it on the slide, often are systems are often run by municipal, local, regional governments. Most of us interact with these types of assets, or the services they provide at least, on a daily basis, including, as you see here again, everything from garbage collection to roads and sidewalks, water systems, to parks. On the regional and national scale, infrastructure systems might include things like ports, airports, health and education facilities, as well as certain infrastructures that support industries like especially primary product industries like forestry, agriculture, fisheries, and so on. And finally, as Ben mentioned earlier, over recent years, the definition of public infrastructure has expanded into nature-based solutions and natural assets. So natural assets are, of course, important contributors to service delivery, whether through protecting water quality, managing stormwater, contributing to positive physical and mental health, and so on, and need to be accounted for and managed alongside gray infrastructure and realizing kind of full value for communities. If we can continue to the next slide, please. So when considering major disasters and emergency events, weather and therefore climate related hazards are responsible for by far the most in terms of direct financial losses. And this is a graph that I'm sure many of you are familiar with, but perhaps some not. So just to indicate that the bars show annual insured losses globally between 1970 and 2020, and the orange line shows the 10-year moving average of these losses. And then each of the bars, the different colors in each bar show the type of hazard that's responsible for different proportions of the total insured losses. And what I want to bring to your attention most is that the weather-related hazards shown in the light blue result in by far the largest amount of insured losses over time, and that the relative share of those losses from those hazard types is increasing. And of course, this trend is expected to increase further because of the impacts of climate change. And in general, often these losses do involve impacts on infrastructure. Next slide, please, Nicholas. So climate and weather-related hazards cause three main types of infrastructure-related impacts. The first is service-related disruption or reduction. In the picture, you see a road where traffic is stalled out, slowed, or stopped. The road, in essence, is no longer delivering the service that it was built to deliver. Of course, impacts also cause infrastructure damage, which can damages that can typically be repaired, but at a cost of time and money, and often loss of service. And then, of course, the third type of impact is kind of all-out infrastructure failure. Next, please. So down the left-hand side of the slide, you see different types of hazards, which, because of climate change, are projected to increase in likelihood and in many cases intensity or severity across many parts of the globe. This is just a sample, so obviously not all relevant hazards, but on the just quickly to walk you through a few examples here. The wildfire picture is from a relatively recent super high profile event in Hawaii, United States in the fall of 2023. Homes and buildings were devastated by this fire, totally destroyed. But even what's worthwhile also pointing out that even those systems that survived, so sewer systems, for example, sustained considerable damage and will not be able to provide services again for many months or years. The next hazard, extreme heat, can also lead to infrastructure damage and service interruption. Here you can see some examples of systems where road and train track materials were not chosen with an understanding of the potential severity of heat events that could start developing across the United States in this instance. Severe rainfall, the third example, shows impacts resulting not necessarily in road failure. Oh, sorry, you can jump there, but I think you're one slide ahead there, Nicholas. Just on the extreme rainfall side, certainly implications for service disruption, but for health and safety and therefore commerce, et cetera, as well. Thanks, Nicholas. If you can move to the Libya example. This one, folks may remember, fairly recent. And just to point out that, of course, severe rainfall can also result in very catastrophic infrastructure failure. On the slide, you see images of the aftermath of torrential rainfall, flooding, and the implications, eventually 2 dams bursting. So this resulted when over 400 millimeters of rain fell in 24 hours from the Mediterranean storm that was called Daniel near Derna, Libya. Destroyed many assets, displaced and killed thousands, and sadly, in this case, there were known structural issues with the dams ahead of time. If you can move on. And so I think as that Libya example especially well demonstrates and reminds us that the impacts of climate change on infrastructure ultimately affect things we care about, including human health, well-being, safety, etc. And with climate change, these impacts are only going to worsen over time. Next slide. So often when people think about climate change, we think about, a few degrees of change Celsius in temperature, and maybe this doesn't seem like much, but if we look, I want to look here at the effect of climate change in the effective change on average temperature the effect that a change in average temperature has on extremes. So on the y-or vertical axis, we have the probability of occurrence, or in other words, the likelihood that a temperature of a certain magnitude might occur. Points that are higher on that axis mean they're more likely to occur. Points that are lower are less likely. And then on the x-axis, we have temperature. So the midpoint of the curve is the average temperature. And because this is a bell curve even distribution, the average temperature is also the temperature that occurs most frequently. And on either end of the curve, we have occurrences of extreme cold and extreme hot temperatures, and their reach is much lower, of course, because these occur less often. And now on the slide that's up, you'll see that with climate change, we see that a few degrees of change in that average temperature to the right towards warmer conditions results in a much more frequent occurrence of hot days, which might earlier have been considered extreme hot days and no longer are extreme, as well as the occurrence of days with temperatures that will exceed any prior heat record. So the shift, again, just to make the case that the shift in averages that may seem less impactful can cause significant changes in the likelihood and intensity of extremes. So where infrastructure is concerned, we see impacts when weather, climate, and other environmental conditions occur that the infrastructure was not designed, built, or managed to withstand or cope with. So in other words, vulnerability exists if the load the infrastructure could experience, again, whether it be flood events, wind, heat, if this load is beyond what the infrastructure was designed to sustain, if it's in excess of the capacity of the infrastructure to cope. So under past climate, as you see on the left, before conditions began to change so quickly, what we expected, we prepared for, and what occurred was more or less likely to be within that range of what we prepared for. And so the gap in the left-hand figure between what we expected and what we got was much less likely to occur. But on the right, given the rate of change, this gap is much more likely to be experienced. And it's these extremes, again, that end up exceeding what infrastructure is able to cope with. So projected loads are starting to more frequently and significantly be exceeded. Just two more background slides here. Nicholas will, like I said, be talking a bit about climate proofing. So ultimately, the goal is climate proofing or climate resilient infrastructure. And the goal here is to adopt solutions and move us towards infrastructure systems that can better withstand and also bounce back from the impacts of climate hazards and climate change. So in green, a climate event like a flood would occur and put too much stress, for example, on a water system and damages it. The operational capacity of the system to deliver safe drinking water is reduced, but not too much. and the regular service level is regained relatively quickly. On the other hand, the red curve, the red line, is what we want to avoid. It shows that unprepared system where the impact to service is more pronounced to begin with, takes a longer time to come back, and may never reach back to original levels. Final slide, and you can click twice there. Yeah. So until recently, engineers have used historical climate records alone to understand the weather and climate conditions that for which they needed to design infrastructure. So design thresholds and values were based on past experience. Therefore, existing infrastructure systems designed based on these past assumptions may not be prepared for what's coming. And as we move from the green box into the red there, and projects that are currently being planned and designed really need to take the red box into account. That's all for now, and on to polling.
Okay, so we'll go back into polling. Okay, should be able to hopefully see that. The question is, what type of infrastructure and climate events are you concerned with in your work? So far, we're seeing water scarcity, hydraulic works, municipal, we have road deterioration, transport, floods, rainfall, and so it's updating the more common answer that gets entered. This is a word cloud, so the font on the word that comes up the most often is bigger. Great. Okay. Looks like transport is dominating. Okay. Okay, we'll move on to the next question, just in the essence of time. So how does infrastructure play a role in your mandate of work? And this is a short answer, so you can type in a few words or a sentence or two. So we have one response: assessments are to facilitate transport. An activity, a risk assessment category, need to adapt to prevent floods, hydraulic works and transport, supply. So a lot of water themes here. Yeah, flooding, service delivery. Okay. Okay, great. So you can continue to enter your responses. We're going to jump back to the presentation now. Pass it back to you, Nicholas.
Yes, I will take over and guide you through a bit the concept of climate proofing. It is, I think, vital for nesting climate risk assessments in governance processes and frameworks. So I would like to start to give you an example. If you see the top left image, that is a case from Costa Rica in 2008 where the bridge has been destroyed, and they somehow tried to climate proof it, but probably not the right way. We would say it's going well. So, but maybe first saying, yeah, exactly. So I will go to the next slide, sorry. And then in 2017, this bridge was destroyed. It was just rebuilt at the same place. And again, the flood came to destroy it in 2017. 2018, the bridge was rehabilitated, but put a bit in a higher level. So there has been happening some climate proofing, but probably without considering climate risk, as you could have seen that the same year, that bridge was again destroyed entirely. In 2019, there was no option now to invest into a climate-proof bridge anymore. So it's a pending issue now how this river will be trespassed in the future. So we can see that we aim with climate proofing to ensure the structural and operational integrity of infrastructure for a sustainable service provision under climate change conditions. So the benefit cost ratio is approximately 6:1 of investments in climate proofing. So climate-proof investments, a key concept that we followed also in the CSI project. But how do we mainstream climate proofing into infrastructure investment decision-making? And this goes, of course, along the investment cycle of infrastructure investments. So it starts with the sector policies and plan and regulation where we consider climate, of course, to see also, is this type of infrastructure also the type we want in the future considering climate risk? And then in project identification, when we understand where the location of the infrastructure should be, or which projects we want to realize, we can use a screening approach to see which sites are probably more feasible to go. And then when we do the project preparation, do the designs of the entire project, we again need to consider climate change. And this is also subject to resource mobilization in terms of also insurance coverage and so forth. We have to consider climate. And then when we construct, because it takes a long time often to construct infrastructures, so climate change, the anticipated climate change might change again. And during the construction, natural hazards might strike as well. And then, of course, we are looking at the entire existing infrastructure portfolio that is operating and maintaining. So if in the upstream process of investments in the cycle of infrastructure investments, climate proofing has not been included, then of course existing infrastructures need to be subject to climate proofing. So all in these cycle steps, and this is the basics, climate proofing is necessary. But what is the process of climate proofing? What does it entail? And how is it different in these different phases? We want to go from a condition of risk to a condition of resilience. And the steps to go there is we need to scope and understand what is the objective of undergoing through this climate proofing or climate risk management process. Then we go, to risk assessment. And that is the key that we would like to talk about and assess the risk treatment needs here. And when we do the risk treatment, we want to, of course, figure out what is the best efficient way using risk assessments to understand, shall we reduce climate change, for instance, by ecosystem-based adaptation? We can reduce the effects of climate change and these critical climate events. We can reduce exposure by preventing it and by retreating as well, but we can also reduce the current vulnerability that we have by increasing the robustness, the protection, and business continuity management. So all these options are on the table and need to be carefully evaluated using risk assessments. And then we have to monitor and evaluate, of course, provide feedback to ensure resilience is being constantly put in. So that is somehow a very simplified depiction of how we perceive the climate proofing approach, saying that in each of these cycle steps, the entire procedure of climate proofing can be applied, but has a different scope and has a different type of risk assessment. For instance, at the policy level, we screen rather over geography, specific climate parameters and see whether there is a certain risk to specific infrastructure. Whereas at the project preparation, we inform through impact threshold thinking, the real design of an infrastructure. These kinds of risk assessments would differ then. And that applies also to all the other components. So it's highly contextual where we apply risk assessments. And I think this is a key lessons learned also. I think we will, as time passes by, we wanted to also to ask you, where do you see issues in this project cycle and where you are engaged in that? But I feel we are way over time and just need to continue to also come to the services that are provided. So I think I will just take the decision to go. So, and these are the lessons learned I want to present to you from climate proofing, because it's not trivial, because we want to develop the capacities in the countries to deliver climate proofing. What does it take? So the project's objective of the CSI was partner countries are increasingly using national climate services in the planning and climate risk assessment / climate proofing of infrastructure investments. So we had a huge pillar on improving climate services, because we should not rely on countries' service provision like maybe Germany or Canada to provide the climate information, but countries should be capacitated to develop their own very tailored climate information that matches the impact thresholds of an infrastructure, for instance. That was one key cornerstone of the project. But then developing these capacities for carrying out climate risk assessment, and when I tell you about the lessons learned, I will tell you that it's not a trivial task as well to carry it out. And it should be maybe not consultants from the north doing it in the future, but there should be capacities in countries to do it. And then to understand and to develop these institutional frameworks for mainstreaming climate proofing in investment frameworks, as I just earlier told you with this cycle. So where in the governance apparatus of countries, climate proofing can be nested and established in a way like environmental impact assessments are mandatory nowadays, but climate proofing not yet. So how can we do that? How can we provide advisory on that? So the key lessons learned from the CSI project has been we have methodological variation in executing climate risk assessment, as I just told you about the cycle, where we have many different entry points and scopes of risk assessments. So also methodology-wise, there is a variation. And who does know which variation or which type of methodology fits which purpose and which scope in the investment cycle? This was, of course, a learning journey that we took through, and not just applying one methodology. But then how to really go through a PIEVC assessment, a risk assessment. What does it take to execute it? Because it is multi-stakeholder driven. It can be as such. And you need process facilitators who know the entire process of doing it, but you need also subject matter specialists who provide highly technical inputs and products, data products, for instance. So how is this process evolving? Who is the knowledge owner of that? Who can implement that and do that for the public sector, for instance? Then data customization of climate information, as I just said, we cannot just say in country XYZ there's 1 degree of increase in the future, but we need to know what are the future intensities and frequencies and durations of certain events happening that would trigger a certain impact within an infrastructure. So if we know the impact thresholds of an infrastructure, which can be very different, then we can know what kind of information we need to know, what kind of climate information we have to have in order to understand under which probabilities these impact thresholds are going to be exceeded in the future. And this is also not a very trivial task, because it involves negotiation between engineers and climatologists to discuss the specific climate information product, but also to acquire the data and to use the best data available, and maybe even to use the latest scientific evidence of global data sets that are available that should be used for customization. So this is all not easy. Policy alignment, we have experience, of course, in this project with alignment with the specific national adaptation plans, what the project has worked on, for instance, to see and to demonstrate the implementation of certain activities of implementation plans. But it's a question how in future climate proofing is being to be used on a mandatory basis. And that's why sustaining and institutionalization is a key question. And the last one, network governance, whole of government approach, maybe even to risk, as risk is so multidimensional and involves different sectors and levels of government and also civil society, where to walk through a process and establish structures for climate proofing relies heavily on network governance mechanisms that we could experience in the countries Brazil, Costa Rica, Vietnam, and the Nile Basin initiatives. So this is a bit the kind of final figures of the project that we just want to show you, because the project is ending actually tomorrow after 7 years. So this is our final event. We have 19 measures to improve climate services, digital platforms, and so forth, providing advisory to our partner institutions to develop their own climate services, executing 12 climate risk assessments. Of these were 114 infrastructures, because we did portfolio assessments, so many assets at the same time to assess, opposing or different to single assets assessments where they go deep. Then we developed digital solutions like a climate proofing platform, for instance, that would be the capacity anchor for any decision maker to engage in climate proofing, to orientate themselves how to go about it. And then 22 policies and guidelines, also latest PIEVC guidelines, more contextualized guidelines, but also domestic, nationally owned guidelines, tailored guidelines from more global guidelines. That's what we accomplished. And we trained a huge number of people, 883, that's a figure now that we have. So that's why we turned into the questions, how can we sustain the results of the project and also get the lessons learned into developing integrated solutions and standardized solutions also. I think standardization in the GIZ world is very important, because we want to, of course, offer and allow for accessing standardized products that are quite visible and easy to understand, but also easy to acquire through a system of service providers that come here. And that's what we are striving to for with this relationship to the Climate Risk Institute, between GIZ and the Institute for Catastrophic Loss Reduction, where we founded a PIEVC Alliance, so-called, where we try to deliver these integrated solutions. And these integrated solutions, you can see the bubbles here, they are termed in this way: a toolbox for climate risk assessment. As I said, variations of methodologies. So we need a toolbox where we can customize, but also deliver standard different tools for climate risk assessments. Providing services for climate information services, because they need to be there. As Benjamin also earlier said, we cannot do adaptation without having the climate information on board. And how can countries deliver that and develop it? A human capacity development to get this all rolled out, what is there in the other service areas defined. Institutionalizing climate proofing, regulative frameworks, codes and standards, provide advisories on policies and planning, incentives mechanisms, but also a kind of location where the growing network of practitioners in climate resilience of infrastructure can self-help them and do peer learning and have access to knowledge portals. And this is where we are hosted. So this webinar is hosted on the PIEVC Practitioners Network that will be explained later on. So we are entering into this. So the PIEVC protocol or the PIEVC services have emerged from the situation in Canada. Probably Eric can tell better, but there had been lots of climate events, of course, already previously happening in Canada. Canada is a vast country with tremendous hazardous conditions, where it was thought then, okay, we need to develop a methodology in Canada, the PIEVC protocol, as it is called then, from 2005 to, say, 2012, it was developed and had been started to be applied in Canada. But then with the project also, with the CSI project, it was carried on to the international, to international countries and to international development cooperation, and conveyed that methodology, so to say, in a PIEVC service facility, including that global expert network that we would like to showcase you today. So there has been happening a divestment of the PIEVC protocol from Engineers Canada to ICLR, CRI, and GIZ. So GIZ has been now involved since quite a number of years and has also applied PIEVC internationally in a huge number of countries. So we want to now go into these modular and scalable PIEVC services. So that is now the moment, I think, where everybody's looking for to get more insights into these services. I'll try to be very fast in the starting, because I would like to, of course, show you how the mechanism between CRI and GIZ is working also, and how the PIEVC Alliance is configured here. We have Climate Risk Institute in Canada as a vehicle to access Canadian stakeholders and services, subject matter specialists and consultants who have applied the PIEVC methodology in many jurisdictions and so often compared to the world, so that it's a huge fundus of capacity that we try to access through this PIEVC alliances, and then provide these PIEVC services in or use them in project design and GIZ's project design, but also when existing projects are trying to acquire these services, they can be delivered through this mechanism. That is just generically speaking about the alliance. But of course, you need to know, what is PIEVC then? So what is the assessment methodology itself? What does it make it so unique? So of course, climate change risk assessment helps to identify and understand which hazards results in the greatest risk that we want to know. What are the risks that exist now and in the future, not only now and in the future? So what are the priority adaptation needs that we have? And the step-by-step process is as such that we go from scoping, defining the elements that we would like to look at. Maybe a single asset infrastructure has so many sub-elements that each of them can be looked at very closely using this methodology, but they have to align, of course, with the climate triggers that they would experience, that they're exposed to. And when this data on the climate side and on the infrastructure side has been collected, we can go through a scoring system based assessment type that would allow it to, if it's necessary, to go through an engineering analysis, or then to go to a reporting that also includes already recommendations on adaptation options. Those can be further figured out using the TBL analysis that is also offered. But this step-by-step process is there to develop a clear picture of the infrastructure system, identify these key climate hazards and thresholds. I think I've just told them now, gather and analyze data and information, estimate the consequences, and the identification of higher risk elements. And this is the risk sorting, risk prioritization process that you undergo using a quite participatory approach, which is more explained in the next slide here. So just a moment. How do we turn then also data into a scoring system? So you see the PIEVC heat map on the top left, where you score the consequences and the likelihoods using the best scientific provisions available. And then you walk through the process using having listed all the elements that you see to the left, to the bottom, and then screening for all the elements, the different climate events that you have identified, and then ranking the risks in the end, and to see how the distribution of elements on a heat map is, for instance. So this example shows there's only one element that is of minor risk, but we have no element that is a very high risk. But there are quite a number who have moderate risks. So these probably are risks that you would need to have treated. And to come up with these figures, it's data-driven, but it's also very participatory. So it's collective wisdom used by different disciplines coming together and agreeing on a value that they would provide. So this requires forth and back, looking into the data, agreement, so that at the end of the process, it's a very defensible product that has been, or risk assessment that has been arrived here. So this very participatory bottom-up process is a unique feature. The assessment is compliant with ISO norm, and we understand that we translate data into a scoring system. So I think the strong role of climate information is also clear, and that is very critical. It is flexible to be adopted to the specific context of assessment. So the methodology as such is quite broad. It is quite clear, straightforward, but once you have specific scopes, then you can tailor the entire approach. And that's what we want to try to showcase you. So what is all about this toolbox? We have developed, for instance, 3 different kinds of toolbox elements that are global, which is a PIEVC high-level screening approach that just allows to quickly screen your infrastructure through and see what are the generic or the general risk trends. But you can also do a portfolio assessment where you assess a huge number of assets of same kind or of different kinds, how you wish, and to screen first. This is often used for policy development, where you first want to look into the assets that you have or that you are responsible for to see which of them do I have to go more into depth and conduct an in-depth PIEVC assessment. What has been latest developed is the PIEVC Green that has this nexus of green and gray infrastructure. So these kind of basic toolbox elements or methodological variations exist, but the PIEVC services also provide advisory on tailoring specific methods to specific requirements in a sector or a specialized infrastructure in a specific country context. So this advisory process, so it's not only about executing climate risks, providing advisory on this and doing it like in a fast track modality that Benjamin was hinting to. So you wanted to have advisory to let somebody do the fast track application, maybe the high level screening, for instance, in a desk study and not so participatory, but others would like to do it really extensive and very participatory, like we did it in the PIEVC Green application in Lesotho. Was highly participatory and took many months, but in the end, it was very nice to see that everybody was sticking to the results and more understood the results of risks also. So it triggers more thinking into adaptation, a more holistic approach, and all of government approach also if you do it really participatory. So and using that toolbox also means there is a provision mechanism for subject matter specialists for specific infrastructure types. So whether it's water infrastructure, transportation infrastructure, there is a vast network of people, advisors who have hands-on experience, practical experience in utilities, how to deal with climate risk and to apply PIEVC. Yes, there are many applications out there. There is a nice YouTube video example from Vietnam. We will show you, we will give you, of course, this presentation. I think we don't have time to go further here, as we have still a lot now on our table, and we are quite far behind time. So I would like to say my last words here until I also hand over. This toolbox also allows, or this service package, this service area allows for this customization of manuals for climate proofing. And for instance, that's what we did in the Nile Basin Initiative. So there's now the NBI has an own climate proofing manual, so that fits their requirements. And that's the same for Costa Rica, for instance, which is termed here the Mercy CR method. So I will keep it now with this, stop here with this first service package, and we'll hand over to Paul, to Eric, I think, with the second one. Thank you.
Thanks, Nicholas. Yes, within the service offering, the second area focuses on a component that Nicholas was really touting, emphasizing the importance of, which is the climate information and related services. And specifically, we focus on delivering, supporting the delivery of, and also helping to build in-country capacity to provide tailored climate services. We've developed this service area by working together with different staff, CRI associates, and a range of GIZ country partners. So currently, the PIEVC Tailored Climate Services Toolkit that you can see there on the screen has 5 main components that I'll just go through quickly here. The first one, the Climate Data Needs Identifier tool, provides an iterative framework. It's developed in in a decision tree format that facilitates interactions between climate information providers and other members of the climate risk assessment team. Nicholas mentioned the importance of facilitating conversations with engineers, for example, to more effectively identify and describe the team's climate data requirements. From experience, we know that this can be one of the most challenging steps of the assessment. Components 2 and 3 describe different functions of the same in-house climate data management and analysis system. So component 2 specifically supports data gathering, the gathering, pre-processing and formatting and quality control and assurance of both observed hydrometeorological, so historical data, and climate projections data. Whereas component 3 provides a comprehensive set of data analytical capabilities tailored specifically to PIEVC assessment requirements. Component 4 focuses on tailoring climate information products like climate fact sheets, climate profiles for stakeholder engagement during the assessment process and following it. And then finally, component 5 is really all about in-country capacity building for the eventual delivery of basic to advanced technical climate services. And this can be done through offerings we have on training on relevant use cases of climate services and climate service guidelines and best practices. If you can just flip to the one further slide on climate services, Nicholas, please. Thank you. Oh, one too many. There you go. Okay, I don't want to belabor this slide too much, but to go into any great depth, but it basically outlines some of the specific functions of the climate data management and analytical tool I mentioned on the prior slide. We call this tool the Climate Change Hazards Information Portal. Has 3 main kind of functional areas. The first is on observed data, and so it allows data sourcing, quality control, and importantly helps to fill gaps and extend data records where possible. The second component focuses on climate projections, including a range of functions like bias correction, calculating information for specific indices and trends. Nicholas mentioned the importance of having infrastructure specific indices that reflect key thresholds of design, for example. It supports visualization, and it also supports development of information directly for PIEVC assessments. So on the PIEVC assessments in particular, the tool then supports computation of climatologies for the specific historical and future time periods that are most relevant for that given assessment. And again, based on the tailoring of indices and ultimately the provision of likelihood statistics that are needed for the risk assessment and risk scoring part of the assessment process. So that's just a quick nutshell of kind of main components of the climate services service offering. And with that, I think I pass it to Paul on the human, on the training side of things, human resource development.
I believe Kim was going to speak to this slide first. Is that correct?
Or is that Katrina? Did you want to speak to
that
one?
Okay. Yes.
Sorry,
Paul. You'll be on in a second. I just wanted to share very briefly about an e-learning that we launched beginning of this year on Atingi, which is a platform used by many GIZ implemented projects. And this is an e-learning course basically to raise awareness of the most important concepts of climate proofing of infrastructure. If you take the whole course, it takes 9 to 12 hours, but you can of course also just look into different modules, including module 4, which is basically a methodological deep dive into what was just explained about the PIEVC and its different kinds of guides like PIEVC Green, the PIEVC catalog. So I encourage you to take a look at this, least of all to get more knowledge on PIEVC itself, but also of course the other modules are quite interesting. The main target groups of the course is infrastructure and climate change stakeholders, so people that want to engage in climate proofing of infrastructure, and also for those of you working on development cooperation or just looking to use such a course for your own context. Currently, we have this course only available in English, but it can be adapted, so it can be taken up by others and translated into other languages if you want to use it in a different language context. I will share the link to the course in a second, so just take a look, and if you have any questions about the course or maybe you want to use it in your context or your project, just get in touch. On to Paul, I think.
Excellent, thank you. Okay, I just wanted to take the opportunity to run through a little bit of some of the capacity development and training opportunities that we have. So our principal course, we've been talking a lot about the PIEVC methodology. So one of our principal courses and training offerings is our course on climate change infrastructure risk. Of course, is this course on that focuses on the use and the methodology of the PIEVC protocol. So conventionally, this course is delivered as a hybrid course with independent and interactive self-paced work in an online course environment. And we would couple that with weekly video conference sessions with peers and the expert instructors. The structure of this course provides opportunities for students to review the content and then work with peers and instructors to apply that content through discussions and case studies in our live sessions. This course covers principles and definitions of risks, discusses the interaction between infrastructure and climate variables, and reviews and practices each step of the PIEVC protocol. Now, the delivery format can, of course, be adjusted based on the project or the partner needs, and we do like to work with our partners to ensure that the delivery is tailored to the local needs with regionally relevant examples and case studies integrated. The next slide. So we have had the opportunity to combine some of this structured learning with ongoing project work, and we find that provides a lot of additional benefit for learners, and then potentially some real benefits in terms of project outcomes. So where there are opportunities integrating the learning and the capacity development with the project or the risk assessment initiatives can be a great approach to take. So when we're able to do this, it helps to make the learning tangible and real and ensures that the partners are able to directly and immediately apply new knowledge to practice. And hopefully that will lead to improved project outcomes as well. So here again, depending on the project structure, we can combine both online learning and in-person training and workshops. Next slide. So in the first slide I presented, you saw how we covered topics related to our central PIEVC focused training course. And of course that course supports the knowledge and climate, both knowledge of climate risk assessment process. And of course both of these are central to our collective efforts to build resilient infrastructure. But naturally, as an individual course, it can't cover that sort of complete range of skills and competencies that infrastructure and planning professionals need to advance the range of approaches to infrastructure and planning that are needed. So there's a range of competencies and a range of skills that are required to advance climate risk assessment, and we do have. Recognizing that, we have developed a whole suite of courses that try to cover some of the range of critical competencies. So what you're looking at, so to address that, so CRI has developed this infrastructure resilience professional credential that exists in Canada for professional engineers in Canada. And you can see some of the requirements of that there, but we've developed some courses and training for a range of those competencies. So for this credential, you're required to complete each of the courses. In this case, you are required to have that professional engineering designation and also to be able to demonstrate applied experience in some of these areas as well. We are also launching a new micro-credential, which builds on some of those courses and integrates planning approaches to adaptation and resilience as well. But as you can see, we cover a range of skills from applied climate science to climate law and policy to management of climate risk. And we investigate the intersections between climate change adaptation and procurement processes, for example, asset management strategies and planning, as well as land use planning. Okay, and then just on to my last slide. Just wanted to show an example here of how the existing curriculums and programs and content that we have can be combined to address human capacity and institutional needs within an organization. In the example that you're looking at, CRI had the opportunity to work with multiple agencies and departments with the government of Suriname, which is a small island developing state in South America and the Caribbean region. So my colleagues, including Eric, who you heard from earlier, working with those government agencies, completed a knowledge and competency needs assessment, and we were able to work with them to develop a learning program that supported some of those desired learning outcomes. In this case, our initial program included courses that were aimed at awareness building among the public and the public sector, as well as more detailed specialist courses in resilience and adaptation for coastal management, and a tailored application of the PIEVC course. One of the project outcomes that we had there included a long-term training plan to address a broader range of competencies and skills and human capacity development within those government institutions, including activities such as train the trainer activities. All right, so that's it. I think I am passing it back now to Nicholas, potentially. Thank you.
I will jump in here. So our fourth service area is institutionalization of climate proofing. And of course, really a key goal of PIEVC related service offerings is institutionalization to help ensure climate resilient infrastructure planning and development become requirements or important differentiators for projects and for on-the-ground practice, of course, to improve as a result. So service offerings related to institutionalization focus, as you can see there on the screen, in four main areas. And I just have a very quick example of each of these. So beginning with policies and planning, an example I have in the bottom left-hand corner is that a whole range of PIEVC related activities in Costa Rica supported by the PIEVC Alliance members were used to help directly inform infrastructure related priorities in the National Adaptation Plan. And specifically, these activities helped to prioritize systems and hazards for further scrutiny, prompted development of the Costa Rican specific PIEVC assessment methodology, MERCI, that we saw on the prior slide, and sparked also a presidential decree requiring that all future infrastructure projects be addressed using the new Costa Rican PIEVC based tool. With respect to laws and regulations, an important area of focus is often code standards and directives that can be cited by those laws and regulations and specify how climate change should be factored into infrastructure projects. So as an example, Alliance members were active in developing standards in action, which is, you can see at the bottom, a plan showing there on the slide, working with the Standards Council of Canada to help prioritize next areas of action to develop new climate and infrastructure resilience standards, and where possible, advance these standards into law. On the professional practice side of things, touching on Paul's area of training, this is another key focus for institutionalization. And the third image on the bottom is a graphic of the climate action competency framework, This was developed by a group at Royal Roads University, and it lays out kind of main areas of knowledge and skill sets, or what are called competencies, that climate practitioners should have. And we're currently working as a PIEVC Alliance to tailor this competency framework to more specific, or I should say, to those professions that more directly work on physical infrastructure, including engineers, planners, and architects. And finally, on the incentive mechanism side, the image on the bottom right summarizes the scoring criteria for the rating of projects according to a framework that perhaps some of you know. It's the Envision framework for sustainable infrastructure. And through this framework, infrastructure projects can be certified based on kind of the extent to which they meet the various criteria. And we're currently working with Envision as the PIEVC Alliance to figure out the eventual integration of PIEVC approaches into the climate and resilience portion of that Envision framework and certification process. So those are 4 examples, kind of linking to the sorts of institutionalization support that we provide in this service area. And I think moving on to the final service area.
Yes, and I will take over here one more time. So another thing we're of course relying on for the work related to climate protection of infrastructure and the PIEVC is community, or having a network of practitioners. We have now applied the PIEVC in quite a few countries, and we were thinking about how to create a kind of community where we can exchange on these experiences, and also any kind of practitioners involved can have this kind of exchange. And we decided to establish the PIEVC Practitioners Network, which is an online network. Nicholas, we can't see the slides at the moment, which is basically an online network where we share the link in a second how you can join, where basically everybody that's involved in some kind of activities related to climate proofing of infrastructure is invited to join and to exchange. This webinar is part of this network, and there will be regular upcoming events, and we're also sharing quite a few of materials. If you could change to the next slide, please, Nicholas. Taking a second to load. Yes. So basically what you find in this network is we have a library of resources and tools. So besides the PIEVC.ca webpage, you will also find quite a few PIEVC assessment related materials in the network. Of course, you will receive regular updates and newsletters, other interesting events in the field taking place there. We are promoting upcoming webinars. Last year, we had a big in-person event in Vancouver of the network, hoping to repeat this at some point. If you want to learn more about this, please join us there. And we're also looking into to expand the program. So we have from time to time other experts available for your questions in the network. And we are also of course sharing information on upcoming trainings and other interesting materials. So you see a QR code to join the network. I'll share the link to join in a moment. It's of course free to join and open to anybody. So please join us in the network.
Yes, thank you very much, Katharina. I hope you're still hearing me. I maybe have network difficulties, but hopefully you can all hear me and see me also. Good. So we are proceeding now. We are coming really to an end where we also would like to show you how can you engage in climate in PIEVC services now. So what are the steps that you would need to go? Of course, you have heard now this webinar, but there is much more out there that you can use to engage with PIEVC services and to scope them and to see whether PIEVC fits your purpose and your intention. So I try to summarize 5 steps first that you would need to go through maybe. Become aware of climate risk of infrastructure. where we have a compendium of information packages for each of these bullets that I would like to say now. So through, for instance, these PowerPoints that we have and movies, we can already aware you about PIEVC, of course. Understanding the different PIEVC services, as you just did, I think is a key issue. And we have drafted a fact sheet about that. But then also looking at all the different variations of services offered and the PIEVC itself, we have a compendium of applications and a catalog of PIEVC, where you can see, like in any kind of catalog, what are the different options to engage in PIEVC. And then we can look in depth into the different guides that exist. You can learn on Atingi what it's all about, climate proofing, but you can also look at all the different reports that PIEVC assessments have produced in one website, where you can click on that website. So I will distribute this kind of chart as a interactive PPT, so that you can, if you click on these icons, that you get to all these resources at once. But the final thing is, when you want to really seriously engage in PIEVC application, you would need to use the PIEVC Pathfinder tool and discuss with your partners and colleagues also the modalities for the use of PIEVC services that can be used as a first scoping tool to engage with PIEVC services and to look also into procurement opportunities and costs as well. And as Katharina said, your engagement in the practitioners network is, of course, highly appreciated. So Katharina, if you could share the different resources with these presentations, with the slide that I just did, that would be maybe a good way forward. But of course, we also have your registrations. We will send all the information, the fact sheets that we have around this to you later. But the PIEVC Pathfinder is maybe a last word to tell about. It's a questionnaire, so to say, to support the selection tailoring of climate infrastructure services. So it's a matchmaking tool. It provides orientation. It is acting as a scoping. I already told you about that. We have a lot of colleagues inside GIZ, but also points of contact at CRI that you can address if you want to engage in PIEVC services. So it's me, it's Katharina, it's Benjamin, it's also Mareike Benfeld, it's Iris at the FMB in Germany, in our internal GIZ think tank. It's Rainer Schwag, it's Sandra Schuster, but it's specifically also Eric Sparling from the Climate Risk Institute to go into this. So we feel happy to see you being maybe interested in this kind of subject matter. So we would have the opportunity now. I know we are very late. We can also close the session by having a last poll about how you like this webinar, but we can also go into some questions we can that you have that we would like to address now. So if you would like to pose questions, please do that in the chat, and then we try to respond to them. But I would maybe hand over also here to Suzanne.
Yeah, thanks. So we do have the dedicated question and answer box. It looks like one question came in asking if the tools are open access.
Yes, I mean, the tools are open access in the way that services can be acquired to get them implemented. And there we have the guidances that are publicly available. And though if you want to be a professional to implement PIEVC services, there's a certain standard that you, of course, need to meet in order to be able to apply PIEVC. Though the guidelines that you can access here through the fact sheets and through the different materials we get, you can use them and make yourself aware what it all means. So the tool is basically explored and is free. Otherwise, if you, Eric, would like to complement, you can easily do. So the PIEVC service directions sheet, it's an interactive PDF. This is the key entry point for you to access all the resources. if you see, Katerina has posted them. Eric, do you want to
Nope,
answer this?
I'm
as
okay,
well?
Nicholas. I'd say the same thing. Yes, all the resources are open access and free, but supporting services like training, etc., can also be accompany that.
Great. So you can continue to ask your questions in the Q&A box. We also have a few survey questions just asking about the impact of this webinar. So the first question is, was this webinar beneficial to your work? That's a yes/no question. The next question is, do you see yourself engaging in resilient infrastructure activities in the near future? Great. Thanks to everyone who's stuck around. I know we've gone 15 minutes over, so. And the final question is, if you answered yes to the previous one, do you see PIEVC Services as a good vehicle for engaging in resilient infrastructure? Okay, I'll stop sharing, but you can continue to enter your questions in the poll in the background. Great. Well, are there any final remarks from our panelists?
Not from mine, though. I would like to thank all of you for contributing to this webinar and listening. 60 people were joining in here, as I could see that. Thank you very much. And I hope we can see you in one or the other context, maybe also engaging in PIEVC services. Thank you so much.
Thank you. Thanks, everyone.
Thank you.
Thank you very much.